Okay, so as in the last video, we have discussed about ionization energy and electron affinity. Alright, so we're gonna study more about these energies today. In today's video, we're gonna discuss about the energies which are involved in the ionic bond, right? But before going towards that, we're gonna see what is electrovalency, right? So our today's topic is what? It's electrovalency. Let me write here the topic first, then I'll tell you what it is actually, right? So electrovalency, right? So now see, if I have, you know what, let's take an example of sodium, right? Sodium sodium now sodium has how many electrons? It has 11 electrons, right? It has 11 electrons, right? Which means 2, 8 and 1, right? And we know that uh, an atom would be called stable atom if it will gonna possess octet rule, right? It has to lower its energy, its potential energy, in order to make itself stable, and it need to have its octet rule completed, right? So that's why we need to remove this one electron, right? When we removed this one electron, here we got positive charge, right? Positive 1. So 1 is the electrovalency of sodium. 1 is the electrovalency of sodium. Now let's take an example of chlorine, right? Chlorine. We know that how many electrons does chlorine has? It has basically 17 electrons, right? It has 17 electrons, which means 2 in first shell, 8 in second shell, 8 in third shell, not 8 however, you know what, 6 in 7 in third shell, right? So 2, 8, 7 makes 17 electron. It needs 1 electron, which means it will gonna gain 1 electron, right? So chlorine gains negative charge, which means it has negative 1, but we don't take electrovalency in the negative sign, we take all the values in positive, right? So its electrovalency would be 1 as well. Now you see, now what you see, wait, electrovalency, that sodium has plus 1 charge, since it will going to lose 1 electron, so its electrovalency is 1. Chlorine must have minus 1, however we don't take electrovalency in the negative values, right? So that's why plus 1. And the electrovalency of sodium and chlorine both are same, that is 1 1, right? So you can take now electrovalency of sodium, you can take now magnesium, right? Magnesium will gonna have electrovalency of 2, right? Then you can take any other atom whose electrovalency resembles with magnesium atom, right? So electrovalency can be same, it can be same, right? So electrovalency is what? Now we can write here the definition, right? Electrovalency is basically the or the gaining losing or the gaining of electrons, but note, all values would be taken in positive sign, values in positive or positive value, right? Positive. So now you see what is electrovalency. Electrovalency is just gaining or losing of an electron. If your atom gains electron, it gets some charge on it, and that is its electrovalency. But you don't need to consider the charge, because charge would always be positive in the electrovalency, right? So now we are just going to discuss about, now basically we have now discussed about energies too. energy term involved in ionic bond? We have discussed about ionization energy, energy required, energy required to um, lose one electron from its outermost shell. So that is what we call the ionization energy. Ionization energy. Then we discussed about electron affinity. Electron affinity, right? Electron affinity, right? This is energy released when an electron is added to the outermost shell of the gaseous atom, right? And third is when metal and non-metal combines, right? When metal and non-metal combine, because we know that basically the ionic bond is the combination of metal and non-metal, right? We know that Na will gonna gain lose one electron, right? And it will gonna have positive charge plus one electron on the outermost shell. And here which energy we gave? We gave ionization energy here, right? This is for the metal. Now we are going towards non-metal, right? Non-metal, for example chlorine, it will gonna gain one electron and will gonna have negative charge, and energy released in this process is what we call the electron affinity, right? Electron affinity. So ionization energy, when metals loses electron affinity, the energy is released when electron is added to the non-metals. Now metal and non-metal combination, right? Sodium plus in the gaseous form plus chlorine negative in the gaseous form, they're gonna form NaCl in the solid form, plus the energy which will be released here would be lattice energy. Lattice energy. So what is lattice energy? Lattice energy is the energy which is released when one mole of ionic compound is formed from its gaseous ions, right? This is what we call the lattice energy. So here we got our third term as well, third term, which is lattice energy. We're going to discuss on lattice energy in very detail when we'll be discussing about Born-Haber process, right? Born-Haber cycle. We're going to discuss about heat of formation, lattice energy in very detail, how to find that, right? For now, lattice energy is nothing but it is the energy which is released when one mole of ionic compound is formed from its gaseous ions, right? So now I'm writing here an example. Which is more ionic, right? Which is more ionic? Basically this is a question, right? So I am writing here four compounds, four ionic compound. NaF1, right? Second NaCl, third NaBr, fourth NaI, right? Now ionic will be more, ionic character will be more if we have metal character more plus non-metal character more, right? Now as you can see, metal Na is same in 4, right? They is same in all of the 4, same, which means now we need to look at the non-metals, and then we need to decide which is more ionic, right? So now see, fluorine, chlorine, bromine, iodine, they all belong from a one group, right? And we know that from up to down the non-metal characters decreases. From up to down the non-metal character decreases, because in the down of the periodic table you can see more, or you can find more metals but not non-metals, which means from up to down the non-metal characters would be decreased. Now metal is same in all of these four. Non-metal must be a non-metal character must be higher, so means iodine characters would be lower in the non-metal side. Bromine will gonna have little bit more than iodide, then chlorine will gonna have little bit more than bromine, but fluorine will gonna have more non-metal characters from all of these three. So the more strong ionic or the more ionic would be Na, not I, sorry, this would not be, since iodide has less character of non-metal. From up to down the non-metal characters decreases, so NaF will gonna have uh, F will gonna have higher non-metal characters, that's why NaF is the more ionic. So this was an example which we did today, and we did energy terms involved in the ionic bond, in which we discussed a bit about lattice energy and we discussed about electrovalency. This was all for today.